Meet Mark. He is 38 years old, earns $65,000 a year as a project manager, and he is currently melting into his driver's seat while stuck in afternoon traffic. His 2019 SUV is blowing air that feels like a hairdryer, and the local dealership just handed him a quote for $2,400 to fix the entire system. Mark is facing the classic gym locker comparison of the automotive world. He sees the $30 cans of refrigerant at the local parts store and wonders if the mechanic is simply trying to exploit his lack of technical knowledge. In this video, we are going to look past the marketing slogans of ice-cold air and run the actual numbers on why modern AC systems fail. We will pin down the logic of why your car might be intentionally disabling its own cooling to save itself from a total mechanical meltdown. Let us start with the first rung of the ladder, which we call the flow floor. This is the most basic level of the system, where your money does more work than any complex repair ever could. Mark's first instinct is that he needs more gas, but the reality often starts with a $20 part. The cabin air filter is the most ignored maintenance item in the entire automotive industry, yet it is the primary gateway for every cubic foot of air you breathe. According to industry standards, a filter should be replaced every 15,000 miles. When it is clogged with dust and debris, the blower motor has to work twice as hard to push air through a brick wall of dirt. This lack of flow does more than just make you sweat. It causes the evaporator core inside your dashboard to drop below freezing temperatures because there is no warm air passing over it to transfer heat. When that happens, the moisture in the air turns to ice, completely blocking the vents. You might notice the air starts out cold but slowly dies after 15 minutes of driving, which is a classic symptom of a frozen system. If you find yourself in Mark's shoes, check this first. If the air is weak but the fans are screaming, your scoreboard starts with a $20 filter before you even look at the engine bay. Now we move to the second rung, the pressure threshold. This is where the chemistry of your car changed forever around the year 2021, when the industry shifted refrigerants. For decades, we used R134A. It was cheap, stable, and you could buy a pound of it for about $10 at any corner store without a second thought. But if you drive a modern vehicle, you likely have R1234YF flowing through your lines. This newer refrigerant was designed to be safer for the ozone, but it comes with a massive shift in the financial math for the average owner. While R134A is roughly $10 per pound, R1234YF can cost between $50 and $100 per pound. A full recharge that used to cost $100 is now a $400 event at a professional shop. Here is the part the slogan hides. These two chemicals are not interchangeable, and if you try to mix them, you will create a chemical sludge that destroys every seal in your compressor. The ports are physically different to prevent this, but many owners use adapters to force the old, cheap gas into a new system. This is a $30 decision that leads directly to a $2,000 system replacement within 6 months. Let us look at the scoreboard for a typical leak. If Mark has a small leak in a seal, he can choose to add a DIY can with stop leak additives for $45. In the short term, year 1 of this decision looks great. He has cold air, and he saved $300 compared to a professional evacuation and recharge. But let us run the tape forward to year 2. Those stop leak additives are designed to harden when they hit air, but they also gum up the tiny expansion valves and internal sensors of a modern variable displacement compressor. By the time the next summer rolls around, Mark's compressor has seized. The scoreboard now shows a total loss of $2,400 for the replacement parts and labor because he tried to optimize for a temporary feeling instead of a long-term fix. This brings us to the third rung, which is the logic layer. Modern AC systems are no longer just mechanical pumps. They are managed by the digital communication or CAN bus system of the car. If your car thinks it is negative 40 degrees outside because of a broken ambient temperature sensor, it will never let the AC clutch engage. It does this to protect the compressor from pumping liquid refrigerant that has not been heated into a gas state. You might spend hundreds of dollars replacing the compressor and the lines, only to find the AC still does not work because a $15 sensor behind your front grille is disconnected. We also have to look at the pressure switches. These are the silent guardians of your engine. If the system detects a pressure that is too high or too low, the ECU will pull the plug on the cooling system immediately. Code P0530 is a common diagnostic flag that tells the technician the refrigerant pressure sensor is out of range. In many modern Toyotas, a B1422 code indicates a compressor lock sensor failure, which is the car's way of saying it has stopped the system to prevent a fire. If you hear a clicking or tapping behind your dash, that is the logic layer failing in a different way. The blend door actuators are small plastic motors that mix hot and cold air to reach your desired temperature. When these plastic gears strip, you might have ice-cold air on the passenger side and desert heat on the driver's side. This is not a refrigerant issue. It is a mechanical failure of the air distribution system. A quick pro tip for this scenario is the 10-second reset. On many vehicles, you can manually reach behind the glove box and move the lever to the cold position for a temporary fix while you wait for the new actuator motor to arrive. Now we must discuss the most critical rung of all, the infrastructure peak. For owners of electric vehicles like a Tesla or a Ford Lightning, the AC is not a luxury. It is a survival system for the battery. In an internal combustion car, if the AC dies, you just roll down the windows and sweat. In an EV, the AC system is often the only mechanism used to cool the high-voltage battery during fast charging or high-speed driving. If the electric scroll compressor in an EV fails, the car may enter a reduced power mode or refuse to accept a charge entirely. It does this because an overheated battery is a significant safety risk and can lead to permanent cell degradation. These electric compressors run on 400 volts or higher and do not use a traditional belt. Replacing one of these units can cost between $1,500 and $3,000 because of the specialized labor and the cost of the high-voltage components. This is why we see U codes, like U351F, appearing on diagnostic scanners. These communication errors tell the car that the HVAC system is no longer talking to the battery management system, leading to a total vehicle lockout. At this point, we need to apply the honest counter. I am not telling you that every mechanic is a saint or that you should never touch your own car. There are times when your system is just slightly low on gas due to natural permeation through the rubber hoses over 5 or 10 years. In those specific cases, a simple top-off can buy you another few seasons of comfort. But we have to acknowledge the behavioral risk. If you are adding refrigerant every single month, you are not fixing a problem. You are pouring money into a hole while slowly poisoning your compressor with moisture. When a pro service is performed, they use a vacuum pump to remove all air and moisture from the lines. Moisture is the ultimate enemy of an AC system because it combines with the oil to create acid, which eats the aluminum components from the inside out. Let us pin down what is actually true for Mark. If he chooses the $2,400 repair, he is paying for the certainty that his SUV will remain functional, and his battery or engine will not be collateral damage to a seized pulley. If he chooses the DIY route, he is gambling on the hope that his leak is tiny and his system logic is still intact. The math says the gamble fails 70% of the time on vehicles newer than 5 years old. Our master protocol for any AC failure starts with 3 steps. First, perform the visual and audio test by checking if the compressor center is actually spinning when the AC is turned to the maximum setting. Second, replace the cabin filter to ensure you are not fighting a flow battle you can never win. Third, look for oily residue on the AC lines, which is a telltale sign of a refrigerant leak mixed with compressor oil. If your compressor is short-cycling, which means it clicks on and off every few seconds, you are almost certainly low on refrigerant. This is the moment to decide if you want to play the short-term scoreboard or the long-term reliability game. We are not suggesting that the expensive path is always the right one for your budget today, but we want you to understand the real cost of the $30 can when it meets a $100 per pound refrigerant system. If you are wondering what happens when we look at the specific failure rates of the new electric compressors versus the old belt-driven units, we will run those numbers in the next video. We run the numbers on the decisions that actually shape the next 20 years of your money. Stay cool and keep the logic at home math honest.